All right, so what we're going to be doing today is figuring out how to come up with the formula to find the sum, where that was given to us before. Now, your homework says to prove that your formula works with induction, and I'm not going to make you do that. We're doing enough with induction before this that I don't think it's necessary to do more. I want us to just be able to come up with this formula. So how we're going to do that is kind of taking it back to what we did early on in this unit. Like the first couple days of Unit 9, we took sequences and tried to write explicit formulas for them. And that's exactly what we're going to do here. We're just going to kind of take a step back in time. But now we have more knowledge, hopefully, to help us with this process. So the best way to approach this, I think, is to just start listing out your terms. Okay, so let's start out with the sum of the first term is just going to be 2. I'm going to list out, we're going to do 5 of these. So I'm going to go S sub 1, S sub 2, S sub 3, all the way up to S sub 5. So our first one is just 2, because that's the first term in the sequence, or in the series. The sum of the first 2 terms is going to be 2 plus 6, which is 8. The sum of the next 3 terms, or the first 3, not the next 3, but the first 3 is 2 plus 6 plus 10, which is 18. And then the sum of the first 4 terms, 2 plus 6 plus 10 plus 14 is 32. Now, we only have the first 4 terms listed here, but we can find the 5th term. What are we doing to find each of the terms in this series? So what do we do to 2 to get 6, and then to 6 to get 10, and so on? Adding 4, right? So that means when we go to find the sum of the first 5 terms, we're going to have 2 plus 6 plus 10 plus 14 plus 18. And what is that, real quick, without having to calculate it? 50, good. Right, because we can take the first 4 terms, which we know is 32, and just add 18 to it. All right, so we've got this list of the first 5 terms of that series. So let's kind of start to analyze this. So I'm going to list out my terms of this. So we have 2, then 8, then 18, then 32, then 50. So this is right back to what we were doing early on in this unit. I gave you a sequence of numbers and I said, come up with a formula that will generate the nth term. And that's exactly what we're going to do now. So it's like we're kind of rewinding a little bit. So I want to address this and think about, what are the ones that I know how to write really easily? So like arithmetic and geometric. So I'm going to check. Is this arithmetic? Well, if it's arithmetic, that means we're adding the same thing every time. So from 2 to 8, I have to add 6. But then from 8 to 18, I add 10. So it's not arithmetic. So we can eliminate that as a possibility. Yes, you're like half a step in front of me, but you are correct, yes. I also would check to make sure that it's not geometric. So 8 divided by 2 is 4, but 18 divided by 8 is not 4. So it's not geometric. It's not arithmetic, it's not geometric. So let's look at some other possibilities. And you had a great idea. Let's look at the second difference. So from 2 to 8, I add 6. From 8 to 18, I add 10. 18 to 32, 14, and 32 to 18, I add 18. Now we can tell from that it's not arithmetic. But if we take a look at the second difference, it's consistently 4. So yes, this tells me it's going to be quadratic. Well, at least we know what kind of formula we're looking at. What it actually is probably more complicated than just k squared. So what I'm going to try to do with this lesson today is give you lots of different ways to think about the pattern and lots of different ways to organize your thinking. So you may not need to do every single thing I'm going to do here, okay? But I'm just giving you ways to think about it. So what I want to do next is take that sequence and organize it as a table. And we've talked a little bit about this. We did this early on as well. So I'm just going to make myself a table. And I'm actually going to give myself 3 columns, and you'll see why in just a minute. In the first column are my K values. So we went from 1 to 5. Okay, and that's straight from what we did over here, right? My K values are just 1 through 5. 1, 2, 3, 4, 5. So I'm just listing my K values, and then what I'm going to do is list out the sum for each number of terms. So the sum of the first term was 2. Sum of the first 2 terms was 8, and this is just writing that sequence that I have over there to the left. Okay, now I'm going to think about the idea that I know that we have to square K. That's going to be part of my formula. By realizing that it's quadratic, I know there has to be a K squared somewhere in my formula. Okay, so let's think about how could we find that adjustment that needs to happen. So what I'm going to do in this K squared column is just square K and write what that is. So 1 squared just gives me 1. 2 squared gives me 4. 3 squared gives me 9. And I could keep doing that until I list those K squared values. Now we've done this type of a problem before. We've looked at how we can adjust that quadratic so that it works. So I've got this list of values that I need to have them look like the middle column. Perfect, right. If we multiply everything in that last column by 2, so let me just slide this over. I'll add on a last column, but if you want to, you can. You don't necessarily have to. I'm just showing you why this works. So if I add on that last column and look at what happens when we do 2 times K squared. So multiply everything in that last column by 2. We get 2, 8, 18, 32, and 50. And these 2 columns match. So what that tells me is that my formula to find the sum of the first K terms is going to be 2K squared. So when it asks you to find the formula, I love how when I do these, my writing just gets bigger and bigger as I go. The formula is just 2K squared, and that's it. That's all you have to come up with. Like I said, in the homework, it's going to say, now prove it with induction. I do not need you to prove it with induction. Just come up with the formula, and you're done. So we took an approach on this where, we listed out the first number of terms that we decided was going to be enough. So I listed out the first 5 sums. Looked at what the pattern was. I decided it was quadratic, so with that information, I made some adjustments until I got it to match. Sometimes we have to look at this a little bit differently. So head to example 3 first. So I know you can label it as example 2, that's fine. But I want to skip ahead here because I think this one has a unique approach that we can take that's a little bit different than what we've done before. This is 1 over 1 times 2. Okay, it's not 1.2. 1 over 2 times 3, and so on. So I'm going to do what I did in the previous one, and I'm going to list out the first few terms. But as I do that, I'm going to try to start looking for some pattern. So what I mean is this. Let's list out the sum of the first term. Well, the sum of the first term is just going to be 1 over 1 times 2. That's 2. But what I want to do is start to think about, is there a way that I could write 1 over 2 differently?
0.5. Oh, well, as a fraction, sorry.
Right, as a fraction. I could write it as a decimal, but could I rewrite 2 differently? I already have it written as 1 times 2 up in the original series. Could I write 2 in another way, though? That's another way I can write 2. Instead of 1 times 2, you could do 1 plus 1. Yes, yeah. 1 plus 1. I know that seems strange, and you'll see why we do this as we work through this problem. So let's find the sum of the first 2 terms. So that's going to be 1/2 plus 1/6. Now here's the thing. I don't care if you can add fractions by hand right now. That is absolutely 100% not the point. The point is add the fractions together and then see if you can find a pattern. So I'm not concerned with how we add these together, but when you do, you're going to get 4/6, which we can simplify to 2/3. Okay, so let's pause for a moment and just look at one thing that's sort of maybe hopefully we're going to start to sense as we go through this. Look at your numerator and how it relates back to your K value. Like, start to look for patterns early on. That for sure is one that I'm noticing that I'm going to watch out and see if that happens in future terms, okay? But then I want to rewrite that denominator again. So I have 2 over, so in the previous term I said 1 plus 1. How could I rewrite 3? Thinking kind of the same way. 1 plus 1 plus 1. I like it. I'm going to simplify it just a little bit and try 1 plus 2. And here's why. I'm noticing they both have a 1 that I can write. And then what do you notice about this second number? It's increasing by 1. It's also exactly the same as our K term, as our K value, right?
I was going to say it's going to be S of 2 over 1 plus S of, not S of 2, S of N, or K.
Let's do a couple more just to make sure we're on the right track. Maybe just even one more term. We'll do one more term. But yeah, I think hopefully we're starting to sense the pattern here. So now we've got 1/2 plus 1/6 plus 1/12. Once again, I am not concerned about you being able to add fractions here. You should be able to add them. But if you want to use technology to help you, that's fine. Just keep it in fraction form. So we're going to get 9/12, which when you simplify that is 3/4. Now, again, let's take a minute and sort of analyze what we have. This 3 does, in fact, match the K value that we're talking about here. And then how could I rewrite 4?
1 plus 3.
1 plus 3, yes, good, good. And all of these, my K value, it can be seen in the denominator as well. So do we have enough information that you think you could come up with a formula?
Yeah.
Okay, so let's see if we can come up with a formula. So what is our formula going to be? What do you think?
S of K over 1 plus S of K.
Okay, I like that you're using the S sub K, except it's just K. Yeah. Yeah, so it's K over 1 plus K. Or it could be K over K plus 1. Like, we could write that either way. It means the same thing. But that's the way we could find the sum of any number of terms. Now, you could do a couple more just to verify it, but, I mean, it looks pretty good to me. That seems to follow the sequence. If you think about why we might need to prove this with induction, remember when we talked about Fermat, he said he thinks he has this formula that can generate odd numbers. And his first 4 worked, but then he got to 5 and he wasn't sure if it worked until 100 years later they figured out it didn't work. So being able to prove something with induction just gives you that for sure way of saying, yes, this works in any case. I don't care right now that we do that because we're doing enough with it on the rest of these assignments. Skipping. Okay, let's go backwards and try example 2. Now this looks deceivingly simple. Okay, it looks a lot like our first example. But we're probably going to have to sort of combine the methods that we used in the first 2 examples that we did. So that idea of maybe looking for the pattern, but then also trying to rewrite our terms to make the pattern easier to find. So sometimes these are pretty straightforward. Like the first two we did, I don't think were too bad, if you approach them like we did. This one's gonna take a little bit of effort. So let's do what we did on the previous few and find the first few terms. We'll go up to the fifth term. This one's not too bad to find 5 terms on it. All right, so S sub 1, that is just 3. S sub 2, that's going to be 3 plus 7, which is 10. S sub 3, that's 3 plus 7 plus 11, which is 21. Trying to give myself a little bit of space to work here. Then we've got 3 plus 7 plus 11 plus 15, which is 36. And then 3 plus 7 plus 11 plus 15 plus what? 19, good. Which will be 55. Now we were able to come up with this in first period. It took a lot of thought. So I'm gonna do 2 things. I am gonna start out with the idea that I'd like to know if this fits the mold of some of the patterns that we've looked at before. With that fractional problem, and I encourage you to do that with the fraction ones, look at the numerator and denominator as separate ideas rather than looking at it as one fraction, okay? This doesn't give us a fraction, so I'm gonna have to look at this as a single sequence. So what I'm gonna do is what we did before, where I'm gonna take those numbers, 3, 10, 21, 36, and 55, and start to think about, does it fit any of the patterns that we already know? Is it going to be arithmetic? No, because we're not adding the same thing every time. Is it going to be geometric? No, and again, to figure that out, you would want to do 10 divided by 3 and 21 divided by 10 to see if they're the same. 10 divided by 3 is 3 something. 21 divided by 10 is 2 something. They're not the same. So it's not arithmetic, it's not geometric. So let's check to see if it's quadratic, because that's one at least that we have some experience with. All right, so to check to see if this is quadratic, we're going to look at second differences. So we've got plus 7, plus 11, plus 15, plus 19. And our second difference is this time plus 4, and plus 4. So it is quadratic. Now, this is where it gets a little tricky. Let's take the approach that we did last time, okay? We're going to continue with that same idea. Approach it like we know how to approach a quadratic. If that fails, then we might need to try another approach. So let's take a look at this. I'm going to give myself a table just like we did last time. Like I said, this one requires a little more thought and work to see if it actually will work. All right, there we go. So I could just give myself 4 columns. I don't know if I'll use all 4, but let's at least start with these 4. So I've got my k values 1 through 5. I've got my sum of each of the k values. So that's 3, 10, 21, 36, and 55. And then the idea that it's going to be quadratic. So I know at some point in that equation, I'm going to need a k squared. All right. K squared is going to be 1, 4, 9, 16, 25. Now, the question I want to ask myself, is there a simple adjustment that I can make to k squared that's going to give me the s sub k values? No. I mean, we look at the first one and it looks like, oh, okay, I could just multiply by 3. But that falls apart as soon as we get to the second term. I think, oh, I could just add 2. But that falls apart as soon as we get to the second term. So we're in kind of a weird place. Like, I don't know what the adjustment is going to be, so probably that means there's multiple adjustments.
Could you take it again, do another like quadratic like comment, like, because 1 to 4 is 3, 4 to 9 is 5, so there's a second difference of 2.
Well, we do know that this is quadratic because it's written this way, right?
Oh, okay, I see.
Yeah, so while yes, you are correct, it may not help us much. You might kind of get yourself in this cyclical thought that's not really moving you forward. But I like how you're thinking. You're thinking about looking at what we have and trying to figure out how to adjust it to be what we need. Let's keep the idea that it needs to be quadratic in the forefront of our thinking process. Okay, at some point we need to have a quadratic. If we go back to the last example, we also saw that there was a way to rewrite each term using k, meaning I did something to k, like I added 1 to it, right? Or I could subtract 1 from it. Can I think about how to rewrite these terms so that they use k? And maybe, or even just thinking about how to rewrite the terms in another way. All right, so 3 can be rewritten. How could I rewrite 3? I can rewrite 3 in a bunch of different ways, right? I can rewrite 3 as 3 times 1. I could rewrite 3 as 3 plus 1, or 3 plus 2. Okay, so let's think about that. We've got, let's try 1 plus 2. Okay, let's think about 10. So there's a lot of different ways I could rewrite 10. I know it's probably not, I mean, we could try the 1 plus 9 thing, right? 1 plus 9. But I'm thinking in my head, here, this 2, I can find a way to use 1 to come up with 2, right? I could do 2 times 1 or 1 plus 1 to get 2. But to get 9 from the idea of 2 is probably not as easy. So let me rewind a little bit. Instead of 1 plus 9, what if I use 2? 2 plus something. 2 plus what gives you 10? 8. Okay. So what if I think about adding k each time, like increasing, so like if I had 3 plus something? 18. What about 4 plus something? 32. What about 5 plus something? 50. Do those numbers look familiar?
From the first example.
Yes, those are from the first example, aren't they? And we know that first example, 2, 8, 18, 32, 50, could be written as what? Go back and 2k squared. So here's what I know. This can be written as 2k squared plus k. Okay, so we know it's got to be a quadratic. It's got to have a k squared in it. But just knowing it was a quadratic wasn't enough for us to find the adjustment. So finding a way to rewrite that 3 and that 10 and that 21. And guys, it's going to sometimes be a process of trial and error. Like I tried 1 plus 2 and then 1 plus 9. And that sort of led me to a dead end. But as soon as I started taking k and adding something to it, that sort of set off a light bulb moment for me. The more you do these, the better you get at recognizing patterns. It's just like anything else. Practice helps you become more of an expert in that area. Do you guys have any questions about this process? So all I did today was give you some strategies. That's it. It's just different strategies, different approaches, different ways of thinking about it that can help you come up with the equations. All you have to do is come up with the equations. I do not need you to write the induction proof for it. We're just going to assume that our equations are correct. Some of these are a little bit tougher than others on the homework, but do what you can. Try to look for that pattern. Start by generating your first few terms and then work from there.